Alright, so in this lesson we're going to talk about the isometric drawing of the servo motor. And this one is for 2.7, just as an introduction for this recording so that we know what we're talking about. 2.7, drawing an isometric. Now most of you are at a point where you've already drawn the orthographic version of this particular servo. Life is good, you're ready to go on to the next step, which is the isometric view. Now let's talk isometric, let's talk how we're going to make it work. Most of this drawing is actually relatively easy to do in isometric. The pieces that are really easy are all the rectangular prisms, and most of this is rectangular prisms. But the parts that are harder are the cylinders, and the cylinders is basically what we're going to talk about here today. Now I'm going to do it in two ways. I'm going to do it in AutoCAD Desktop, and I'm going to do it in AutoCAD Web App. And the web app doesn't quite do this as well. It doesn't deal with ellipses particularly well, and so we're going to make sure that we show the workaround to actually work our way through ellipses in AutoCAD Web App. So let's go to AutoCAD. Very quickly, I'm just going to drop a drawing layer in here so that we can actually see what we're drawing. And what I'm going to do, just for everyone's reference, is I'm actually going to go over and I'm going to take this drawing from here and I am going to throw it over onto my other screen so that I can actually see what I'm doing and have all my dimensions in front of me. Okay, with that being said, let's get this party started. When we start drawing something in isometric, okay, we are going to start with usually the major, the kind of the first piece that we're going to work with. I'm going to start in my draw layer, and in this case that's a rectangular prism. In this case, and I'm going to keep my properties here, I'm going to start my prism and I'm going to draw it to 30-degree angles. Now, you guys remember, I've done most of my tutorials in Web App here, but there is actually the ability with the Restrict Cursor to Specified Angles button down here at the bottom that's going to allow me to actually set my angles to my snaps to 30 degrees, which is exactly what I'm going to do. Okay, I like 30s because 30s let me draw isometric very easily. Okay, now I know that in this drawing I've got a 22.5 unit, I think it's millimeter in this one, long section on the bottom of my servo. Okay, the height of the servo overall is going to be 22.7 millimeters. Okay, and then relatively easily I can just use my ortho snaps to finish off that front plane. Okay, that part was easy. Okay, we're going to draw the piece back here, and again the servo is going to be, I believe, 11.8 millimeters deep here, and again I can just use my snaps. Oh, it's not going to give me that one. Okay, 22.7, snap back, and I'm just going to finish off the, come on, you can load AutoCAD, there we go. I'm just going to go ahead and finish this off at 22.5 and finish off. Okay, there's our first rectangle. Life is easy on that one. Now, the next pieces of this that we need to draw are going to probably be these wings on the bottom, because we may as well be doing that while we're here fighting with a rectangular, what is really a rectangular prism for right now. Okay, so very quickly I'm going to take, and I know that these start 15.9 units up from the bottom here, and I'm going to use a construction line for that. Okay, I'm going to draw the entirety of the rectangular prism as if I could see through it in this case, because it's just going to make my life relatively easier in this sense. I know that this is 4.7 units out, and I know that it goes back across by the width of the object here, which is 11.8. Okay. Now, that's the bottom edge of the rectangle, and I'm going to show you a trick here. We're going to use a left to right select to actually select that, and I'm actually going to use a copy, because this is where this gets fun. I know that the top of this, I know this thing is 2.5 millimeters tall, so if I copy it and I go straight up 2.5 millimeters, I can actually draw the other piece of it. Ooh, don't want to do that. I can actually draw the other piece of it relatively easily and just kind of fill in the gaps for what would be finished there, just like that. Okay, now that I'm looking at this, I can see that, this line is a line that I would never see, this line is a line that I would never see, and then I can just trim away the pieces of the line. Oop, that was the wrong command. Trim, enter, okay, enter, and I can just take out the pieces of the line that I probably would never see on this particular drawing. There's my one wing, relatively easily, okay? Now, the other wing I can do in the exact same way if I really want to. It's actually not that hard to do at all. I just take the line up, construction line 15.9 up from the bottom. Okay, I go out at a 30-degree angle. I know that this thing is, I'm clicking more buttons than I'm supposed to here. I know this thing is 4.7 millimeters out, and I know that it runs straight across at a 30-degree angle. Now, if I look here, this is where this gets kind of neat. I know that I'm not going to be able to see the rest of this box, so I'm literally just going to stop it right there. Okay, I'm going to draw my line up, and I have choices here. I could take this and I could do the copy thing again, no problem. copy it up 2.5 millimeters. Okay, that's relatively easy. That's actually showing me that the top of this top line here, it is actually going to be visible. So I'm going to redraw it. Okay, I'm going to draw it out, and I know that it is going to be a length or width of 11.8 based on the drawing. Okay, and I know that it goes back at a 30-degree angle, so I can just draw it there. It's kind of hidden. It's mostly out of the way. Finish my line here. Realize that this line will never be seen. Delete it. There's my other wing. That's relatively easy. Okay, now this is where this gets weird, because now we're going to be dealing with cylinders, because the next part of this drawing is the slightly more difficult piece of actually putting these cylinders on the top. I'm actually going to finish the cylinders on the bottom here, and I'm probably going to finish this one as well. This one's relatively easy. So let's start on these cylinders on the top. I know that a cylinder is just a circle with a circle on top of it. Really, that's the external geometry if I'm building a wireframe. So let's go back here and let's draw the first big circle. And I know, based on my drawing here, that the first big circle is based on, it's centered in the middle of the servo. It has 5.9 millimeters from the edge, and it has a radius of 5.9. So that means that this left edge here, this edge right here, is going to actually be lined up at the center point of the side of this this rectangle, which is going to help me later. It's going to make my life a little bit easier. So let's actually go ahead and draw this thing, okay? Now, if I put a circle here, I run into this problem. I'm going to put the first line here, add an orthographic 30 degrees, sorry, an isometric 30 degrees, 5.9 units in. If I draw a circle here, and I draw a circle right to the edge, you'll notice that it doesn't work. It doesn't quite look right. That's because isometric, that circle would have been kind of rotated off to one side. It sits more flat. It's not an actual circle. It's what's called an ellipse. And you guys have run into ellipses before, I'm pretty sure. Now, in order in AutoCAD to do an actual ellipse, we have to do something kind of weird. Right now, notice my grid in the back is just straight up XY direction. I have to go down here to this tool down here called isometric drafting, and I actually have to apply an isoplane to this. Now, if I put an isoplane left on it, notice my cursor, it's actually looking like it's going to draw something on this plane of the servo mode, or servo in this case. Okay, if I go isoplane left, it's going to look like it wants to draw something here, and if I go isoplane top, it's going to look like I want to draw something here. Now, my circles I want going in isoplane top, and I want to actually draw something called an isocircle. So I'm going to go over to my ellipse. I'm going to go elliptical arc right at the bottom. Yep. And now you'll notice at the bottom it gives me the option of drawing an isocircle. Now, when I click isocircle, it says specify center. I'm going to click the center, and then I'm going to draw the radius of the isocircle out to that point that we talked about, which is the edge of this particular servo motor. Notice that when I click there, and I'm just going to click there, I got to click there a couple times to finish off if I want to do a full circle. That's actually going to give me a circle that is in isometric. Notice how that looks right. Like that looks correct, like a circle would be in this actual drawing. Now, in this case, we're going to draw the second circle. The second circle is a bit smaller. It is, if you follow your drawing, it is going in this direction, 10.6, that direction. Okay. Notice that this line doesn't quite line up with that line. They're close, but not quite. So I'm again going to go to my ellipse tool. I'm again going to click here, and I'm again going to, oh, sorry, I did not click isocircle that time. Isocircle, there we go. You click on the end of this, and I'm going to draw out an isocircle. This one has a radius of 2.5, so we're going to go 2.5 for the radius, and we're going to draw it in there, okay? Notice that my next thing is I'm actually specifying the start angle, okay? I'm just going to pick an angle, and then it says specify end angle. I can draw a partial circle. I want a full circle, so I just draw it that way. Okay, I'm very simply going to delete the lines I don't need using a trim command. I can make them go away. And now I have the base of this circle. Okay, I'm going to use the exact same thing I used on the wings. I'm going to actually just copy it. And I'm going to pick a base point in the center here, and I'm going to copy it its exact height, which is 4 millimeters. Okay, now in reality, if I'm looking at this particular object, this is where this gets a little bit weird, because this is a cylinder. Okay, right now you're seeing what's called a wireframe. And the cylinder itself, it looks kind of weird because we're actually going to see the edge of the cylinder going in a line straight 90 degrees horizontal right now to each of these circles. Okay, I'm going to go to this circle too and do the exact same thing. Okay, notice that I just create a construction line to make sure that I get right to the 90-degree tangent to this. Okay, there we go. Now, this is just a matter of trimming away the parts that we no longer require. There, it's going to take those out. We're not going to see them. We can't delete that line because that line right now doesn't actually intersect with anything in this drawing. If a line doesn't intersect, it can't be trimmed because there's nothing to cut it with. Okay, now what we have is the actual top of this servo. Okay, the last piece is actually really easy to do because it's just a circle on top, and I'm just going to draw it out. It has a diameter of 4.6 if I'm looking at this correctly. Start in the center. Okay, oop, didn't click ISO circle again. My bad. Let's do it right. Okay, here we go. 4.6. Okay, love it. That was a radius. We didn't want a radius. Let's try it one more time with an ISO circle. Here we go. This time the radius, if it is 4.6, is going to be 4.6 or 4.8? 4.6. Okay, let's go 2.3 on this one. Okay, for the radius. There we go. Start angle, end angle. Oop, that didn't quite work. I'm going to extend this and see if I can just quickly fix it. Nope, cannot. Time to redraw. Do it one more time. Okay. Apologies, let's do this properly. Okay, I said 2.3, and we said we were going to specify the start angle, we were going to specify the end angle, there we go. Okay, and I know from my drawing that this thing is 3.2 units high, so we're going to copy it, and we're going to go straight up 3.2 units, and then we're just going to finish off our lines so we make sure we get the right visible things, like so. Okay, do some trimming, do some deleting. There and there and there, and I actually have to zoom in to find this last line that I'm going to delete. And there's most of your servo motor done. Okay, I'm not going to walk through how you do the wings. I think that should be a challenge you should try to finish here. But I'm gonna quickly draw them. I'm not going to talk our way through them because that's going to make life a little bit too easy for you, I would imagine. Okay, but all the skills that you've used already here will definitely apply in this particular drawing. Okay. Off this side, it is 0.65. Again, all the pieces that you've got are going to be relatively easy. Now, this is where this gets interesting, because drawing this in AutoCAD proper is not exceptionally hard to do. I mean, this has not been a terribly turbulent drawing as one is, necessarily. There are a few pieces of weirdness, of course, that you might have to redraw and tidy up. But doing it in AutoCAD Web is a little bit harder, because AutoCAD Web was never really made to deal with ellipses like the ISO circle. And so we're going to do a workaround. Let's talk about that workaround right now. There's the front edge of your servo motor. That's how it's supposed to be done. Now, let's talk about AutoCAD Web, because that's where this gets weird. I'm going to go to my test folder, okay? I'm going to go show you, the exact same thing, but the problem is there's no ellipse in AutoCAD Web. So my expectation for you is that you take and use the workaround I've kind of created for you. If you go onto the main assignment page, if you float around here, and oh, it looks like it has not yet published. Hang tight for a second. We may have to hit a publish button here to make this work. Apologies for that. Let me just make sure it loaded properly. It did not. Okay. I will update the workaround on here. I did have it drawn in here this morning, but clearly didn't hit the correct button. Oh, here it is. Never mind. I take it back. Okay. Give me one moment to hit the publish button and to refresh this page. All right. Give the server a moment to update. Come on, Google. You can do it. Last try. There we go. Okay. Here's the workaround. In your assignment folder, no, let's not open Illustrator. In your assignment folder, I've actually left you a couple files. The one that you care about is the ISO circle top. I want you to actually take it, download it, so that you have it on your computer. We're going to actually do this version of this right now. Sorry, apologize. I accidentally opened something I wasn't supposed to open. It can go away. Go away, Illustrator. All right, now we're paused. Don't you love it how software does that to you sometimes? Okay. There we go. Okay, let's take our ISO circle. Let's download it. Okay? From here, what we're going to do is we're going to take that downloaded DWG file, we're going to go into our web app, and we are going to upload and go find that file. Okay? Nice and easy, nothing complicated there. Okay? That's going to allow us to actually have access to that particular file, which is really honestly something that we need. And there we go. Okay, cool. That being said, we now have that isometric top, and it's uploaded. I think I uploaded it. ISO circle top right here. Now, this is where this gets weird. If I open this file, okay, this is where it's nice. I actually have the ISO circle that we just drew, and I was nice to you guys. I turned around, and when I drew it, I actually created it with a radius of exactly 1 in the isometric direction, okay? How you're going to work with this is really simple. You're going to take this circle, you're going to take this file, and you're actually going to save it as your isometric servo, okay? Where's our save as? There's our save as. It doesn't seem to be saving as. Interesting. ISO circle. No. Hang tight for a second. I thought this would save as. I apparently was wrong. That is interesting. Okay, well, I guess you're doing your drawing in something called ISO circle top at this point. Such is life. We'll make it work. Nothing wrong with that. That being said, how you're going to make this work is using another command we haven't really touched yet. Now I know that I've got this circle, and I know that on the top of my servo, I'm going to need that circle. I'm going to actually just turn my polar snaps onto 30. I'm going to do the exact same drawing we just did really quickly, just so that we can actually have something to work with, and I can walk you through those pieces. I just have to quickly pop open the drawing I need to actually see the servo. There we go. Okay, let's take this over. This is 22.5. I've lost control of my screen. All right, there we go. Okay, I'm just going to make sure I have a canvas to work off of, which is all this is, so that we can go. Hang tight, guys. Appear to have turned off one of my tracking buttons here. Interesting. Interesting. I'm trying to figure out what we've actually done here. Apologies, guys. Zoom window. Test folder, ISO circle top. I may have to save this as something first. Hang tight for a second. I just want to see what options I have with this ISO circle. Okay, here we go. I'm going to duplicate it. And I'm going to see if a duplicate version of it can be modified, because I think I'm running into a file type problem here, oddly. Okay, let's see if we can edit this one. Okay, I just want to make sure I can draw on this one just like I normally would. Hey, here we go. We appear to have fixed it. 22.5. Okay, good. Bye. I'm just going to move this circle out of the way so it's not around, and then I'm going to quickly put the rest of my drawing together. Apologies for the delay, guys. We'll make sure we get this to work in AutoCAD Web here. 22.5. Just 22.5. There we go. I'm going to use the same trick I used before, and that I'm just going to copy this straight up the height of the thing, which is 22.7. Okay, and then I'm simply going to move my screen a little too far there. I'm simply going to, there we go, finish off the lines that I would normally have here, meaning that line would be visible, that line would be visible, there we go. That line would be visible, and these lines would be invisible, so they get deleted. Okay, now, this is where this gets interesting. I want to reuse this iso circle over and over again. So I'm just going to draw just the top of this because you've seen me draw the rest of this drawing in AutoCAD Desktop. But in order to use this, I now have to do something weird. I'm actually going to make a copy of this, okay? And I'm going to copy the iso circle up here. But clearly that iso circle is the wrong size. It's not what we need. Okay, so we're going to actually use what's called a scale command. Okay? Scale is going to allow us to actually make something larger or smaller than it normally is. Okay? Now in this case we want to scale it to a very specific dimension. So we're going to actually go scale, and we know right now that it has a diameter of 2. We know that we want this to have a diameter of 11.8 if we're going by our measurements on our drawing. So we know that in that case we have to scale this by a factor of, well, let's make the math easy, okay? Let's specify our base point as the middle, and let's make our scale factor 0.5. Now I know that I have a radius of 0.5 and a diameter of 1. If I know that my diameter is now 11.5, I can very easily just take a scale command and I can scale it around the base point of the center, and I can scale it by 11.8. And that's going to give me a circle that's exactly 11.8 wide. A diameter of 1 at a scale factor of 11.8 becomes a diameter of 11.8. That easy, okay? And again, now this is going to work exactly the way it did in our other tutorial, where we can do pieces of this, we could displace things, we could draw the rest of the cylinder, and you can actually finish your servo motor in relatively short order, putting it in raw 2D isometric. Now, if that all makes sense, I'm going to stop the recording on the video here, but that should give you enough information to actually get the drawing of your servo motor complete, and I'm hoping put together with your orthographic and exported. I'm going to stop the recording right now, and we'll go back to the chat.